1.6.1, just some basic ideas about what you're going to be dealing with in this section. So first off, you deal with a lot of graphing. And graphing takes place on what's called the coordinate grid. And this is your x-axis, this is your y-axis. And we always go in alphabetical order, x then y, when we're graphing. So out here, positive, up is positive, left is negative, and down is negative. If you think about it, it kind of makes sense. When we think about things in the real world, time moves on, increasing as it goes forward to the right. When gas prices go up, that may not be positive to our bank account, but it is the increase in the numbers. So basically what happens is we have quadrants here. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And every number out here in quadrant 1 is positive, positive. In other words, you go right, and then you go up. Everything in quadrant 2 is negative, positive. In other words, you go left first, and then you go up. We're always starting right here at the origin. And the origin has a location of 0, 0. Down in region 3, everything is negative, negative. Because you go left from the origin, and then you go down. And everything in region 4 is positive and negative. Whoops. In other words, you go right, and then you go down to get to anything in region 1. Now, anything that falls on the x-axis, okay, notice, you go left or right, but you never move up or down because you're remaining on the axis. So, the x-axis is always going to be some number, positive or negative, and then a 0 for y, because you're not going to move up and down. Consequently, anything on the y-axis right here, notice, you're going up and down, but you're never going left and right. So for the y-axis, you are not moving left or right. It's 0. And then you're going to go up or down. So this is going to be, left or right based on whether it's positive or negative, and it's going to be up or down based on positive or negative number. Again, up is positive, down is negative. Left is negative, right is positive. And that's how we graph numbers on the coordinate grid. So there are some special things here when we're doing this. Well, real quickly. For example, if I was going to graph some points like negative 3, 5, 4, 0, 2, 4, and negative 8, negative 8, for example. And I give you A, B, C, and D. Well, negative 3, 5, remember, we go left 3, 1, 2, 3, and we go up 5, 1, 2, 3, 4, 5. So point A, get a graph here, would be much better. Be right about there. B, you go out 4 to the right, but then you do not go up or down. It's on the axis. 2, 4, 1, 2, right, 1, 2, 3, 4, up. And there would be C, and negative 8 would be 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Somewhere out about here, okay, right by the D. So that's how we graph basic points on a number line. Now, there are special lines, and that's when we have x equals a number or y equals a number. And these are special lines because what is happening here is x is always the same number. So, for example, if I wanted to plot 3, 1, and 3, 5, and 3, negative 2, and 3, 0, notice that my x number never changes. The y value does. So in other words, I'm going to go left, I'm going to go right 3, 1, 2, 3, and then I'm going to go up to 1, up to 5, down to 2, down to -2, at 0. And notice what I get. I end up with a vertical line every time. Because my x-coordinate is always the same. It never changes. Y does, but x doesn't. Consequently, what do you think is going to be a y equals line? Well, yes. It's going to be horizontal. Why? No pun intended. Let's see. If I had something at -1, -2, and 5, -2, and 3, -2, and 0, -2. Well, let's see. -1, 1, -2. 5, 1, 2, 3, 4, 5, -2. 3, -2. Same spot. 0, -2. And notice what I have. Horizontal line. Why? Because my x-coordinate is changing. I'm moving left and right, but I'm only going 2 down every time. It never changes. Okay. Now, part of the lesson also talks about graphing using a table, an XY table. And an XY table is just take the equation, and usually you'll be given numbers. So, for example, if I said my equation is y equals 2x plus 5, and you were given the values of -2, 1, and 3, what this means is you're going to take -2 and plug it in and do 3 equations basically. Y equals 2 times -2, which is my x, plus 5, and see what you get. Y equals 2 times 1 plus your 5, and see what you get. Y equals 2 times 3 plus your 5, and see what you get. So the first one, 2 times -2 is -4. 5 minus 4 is 1. 2 times 1 is 2, plus 5 is 7. 2 times 3 is 6, plus 5 is 11. And then you could go ahead and put those points on a grid and connect the dots, and you would have a line. Now, you can know it's a line already because your x value is to the first power. And that's always going to be a linear equation. Now, you're also introduced in some of these to values that have an x squared. Well, an x squared is what's called a quadratic. And its graph is not a line, but a parabola. And a parabola is a smile or a frown. And if you think about it, a smile is happy, so that's positive. A frown is down, it's negative. And that is what a quadratic looks like whenever you have x squared. You're also introduced in this chapter to the idea of what's called the absolute value. And the absolute value is the distance from 0. And it's always going to be a positive number. Well, I use the analogy of way back when you were first able to go trick-or-treating by yourself. Usually your parents probably said, okay, you can go out by yourself this year, but you can only go 3 houses up the street and 3 houses down the street. Or 3 to the left and 3 to the right. You were given a positive number, but you were given a limit. And that's what absolute value is. Your house is 0. There's your home. And if you're given an absolute distance of 3 houses, that means you're limited to go and travel only between -3 and 3. And the sign for absolute value, the symbol, is these bars. So if I have something like y equals x plus 2, and I'm given some numbers, or I make up my own numbers to graph this, plug them in. What you do is you plug in the negative 1, and you do y equals the absolute value of negative 1 plus 2. And you say, well, what is that? Well, y equals 2 minus 1 is 1. And you ask how far away from 0 is 1? 1. And you do with 0. Y equals the absolute value of 0 plus 2, which obviously is 2. How far away from 2 is 2? 2. How about let's make this a negative 4 instead, just for the heck of it. So I'll do that over here. Y equals the absolute value of negative 4 plus 2. Well, that is the absolute value of negative 2. But once again, thinking about the Halloween story, how far is negative 2 away from 0? It's still just 2 spaces. It doesn't matter whether it's left or right. And the interesting thing about absolute values is your graph ends up being in a V shape. Either positive or negative. And the way you would make it negative is if you had a negative sign out here. Because then what it does is it takes every number you get from the table and makes it the opposite. And that's how you can get an upside down absolute value. And last but not least, you're given some formulas in this section. And one of them is a classic formula. I'll change this up a little bit. Okay, and this is a formula where h is height in terms of time. In other words, as a function of time. As time changes, what happens to height? Okay, this number here tells you the starting point above ground. So you can tell that this means I'm throwing something from 12 feet above the ground. It could be I could be standing on a chair and I'm throwing something in the air. It could be someone who's 8 feet tall and with their arm up in the air. It's 12 feet. That'd be a really tall person, but whatever. And this number here is initial velocity. How fast is it going when it starts? Okay? And what happens is this negative, kind of alluded to that earlier, that tells you that it's going to be an upside down parabola. So this is the classic idea of throwing a rock in the air, a rocket shooting up and coming back down. It's eventually going to hit what's called the highest point right here. And the highest point, we'll get into this later, is called the vertex. But it's going to start somewhere and end somewhere. But all we're doing right now in this section is just plugging in different amounts of time. So for example, I say, where will it be in 3 seconds? Well, all you're going to do is take 3 and plug it in for t, because that's time. So you're going to take and do the formula. Negative 16 times 3 squared plus 60 times 3 plus 12. And then you're just going to crunch the numbers. And so you're going to do 3 times 3, which is 9. And then do 9 times negative 16, which is negative 144 plus 60, sorry, that should be a plus, 60 times 3, which is 180, plus 12. So that's 192 minus 144. Which is 48. Which means in 3 seconds, you'll be at 48 feet. Now I can do that with any amount of time. I can put 10 seconds in and whatnot. I will get different amounts. Now eventually I could put in a time that would give me an error because, in other words, it's past the time it's going to come back down and land. Now when I say error, you'll get an answer. Okay? You'll get a negative answer. But if you think about it, if I throw something up in the air, it can't go unless it's like, a rocket that's going to have some velocity to dive into the ground, dig into the ground. And it might actually bury itself in the ground when it lands somewhat, but it won't keep going on forever drilling through the earth. So eventually, a number we plug in does not make sense in real life. But mathematically, you would just get bigger and bigger negative numbers in a situation like that. So that's pretty much the majority of what Chapter 6, Section 1 is about. And we'll move on to Section 2.